Alright, back in chapter 1 we talked about sequences, and at that time I told you they were going to come back, and here they're back again. So 3.7 is recursive formulas for arithmetic sequences. The new part's going to be this arithmetic or arithmetic, I would call them, sequences. That's going to be the difference. I'm assuming you're remembering some of the stuff about recursive formulas. If you don't, you could quick pull up the video for section 8, 1.8, 1.9 and look at it again, but my guess is you'll be fine just with seeing it here. First thing though is just what is a sequence? And a sequence, we said before, is just a list of numbers in a certain order. So a sequence is a list of numbers in a certain order. And at that time you could get from one number to the next in a myriad of different ways. Now that we have an arithmetic or an arithmetic sequence, you know that you have to get from one term to the next by adding or subtracting, because subtracting is just adding a negative number. So for this, you get from, instead of saying one number to the next, we call them all terms. The first number is the first term, so I'm going to say from one term to the next by adding. I'll include the or subtracting. But just so I can feel good about myself, I'm going to, after the or subtracting, say adding a negative. So adding a negative. So this chapter is a little bit easier, I'd say probably, because one, you've seen sequences before, but two, we know you're going to get from one number to the next by either adding or subtracting. D then is going to show up in our equations. D is the constant difference. And if you get a question that were to say like, hey, what's the difference in your age and my age, or your weight and my weight, or something like that, you'd go through and you'd subtract the two numbers to figure out how different are they. You do that same thing when you're trying to find D. How are you getting from one number to the next? That D, if you're ever trying to find D, I'm getting a little ahead of myself, but D is going to be any number in the sequence. We said the nth term minus the one before it. If you think back to chapter 1, we said that the previous term, always in the subscript, has a n minus 1. Because if this is your third term, t sub 3, n would be 3, this here is going to be a t sub 3 minus 1, or a t sub 2. So you could find that constant difference by taking the third term minus the second term. So that'd be how it would work. Alright, moving on to the next page. Instead of t's, because we're talking about arithmetic sequences, it's going to be a capital A pretty much is what they use every time. And when you see that, then you know that it's going to be one of these arithmetic sequences. So a sub n then is going to be the nth term. Like I said before, I kind of got the cart before the horse, and the last thing I didn't go over these yet, but a sub n is the nth term. A sub n minus 1 equals the previous term. And recursive formulas, thinking back to chapter 1, they always had two parts. And the first part is just going to give you the first term. So two parts. The first one is the first term. Once in a while, they give you more than one, so I'm going to put the little s there in parentheses. But this one here, as you write one of the formulas, generally it's just going to be a sub 1 equals some sort of a number. And then the second thing is going to be how to get a term, how to get a number from the 1 or the ones, so I'll put my little s in parentheses again, the 1 or the ones before it. And that is going to show up in the equation as a sub n equals the one before, a sub n minus 1. But now, because we know we're either adding a number or subtracting a number, and subtracting is just adding a negative, we could do a plus d. This is important. That's going to be the general form for a recursive formula for an arithmetic sequence. One comment worth making is when you have these equations, the two things that you fill in are going to be one right here. What is the first term? And the other, I'm going to underline the plus as well. You fill in the d, because if you're going up, it's going to be plus some number. If you're going down, it'll be plus a negative, which just turns into a minus some number. But these are the two blanks you fill in if you're trying to get an equation. And let's do it. So we want to go through and write a recursive formula for these two sequences. So this first one, I'm going to just start out with my a sub 1 equals, that's the easy part, the first term is 19, so a sub 1 equals 19. Then the second part, and by the way, make sure your subscripts are actually below. It's real common that people start out with a sub n, and then they just kind of gradually work their way up, especially over on the right side of the equal sign. Make sure your n and your n minus 1 are clearly below. Now if we look here, if you're not sure, you could go with what I'd said before, that you take a term, if you want to find d, take any number in there, 14, subtract the number before it, and I get a negative 5. So my constant difference is going to be a negative 5. So you could say you find the nth term by taking the one before it and subtracting 5. If this is actually going to be an arithmetic sequence, that should work for all the numbers. So 9 minus 14 would also have to give you a negative 5. 4 minus 9 has to give you a negative 5. If any of those don't equal negative 5, you don't have an arithmetic sequence. Drawing the curly bracket is sometimes the hardest part. So okay, so that's our first one. Our second one, we go through and do those same steps again. Say the first term is, you just pull up your first number, your 3. So first term is 3. Then you say the nth term is going to equal the term before it. So a sub n equals a sub n minus 1. And we're done with the subscript now. Now we're going up, so I can put my plus in and make sure your plus is not a subscript. And figure out what it is. A lot of people just look at it, it's like it's 9. But if you're not sure, take a number, subtract the number before it, and you get 9. And that works whether you do the 3 and the 12, or the 21 and the 30. 30 minus 21 also gives you a 9. So that would be two examples then of writing a recursive formula given the sequence. I want to be able to do that same thing but backwards. So now I have a couple recursive formulas here. We want to write the sequence from them. The book, I think they ask for 5 or 6. I'm kind of in the habit of saying, what are the first 4 terms? And if people mess up, often it's on the first number that they take and do something with the 7. But you just say, hey, first number is a 7, so just pop that in, you're a quarter of the way done already. Now this bottom line here is saying any term, a sub n, is the one before it plus 1. So we actually do 7 plus 1 is 8. That the most common mistake is people say, oh, this is the previous term, 7, then they subtract 1 from the 7 because of that, and then add 1. Nope, this whole thing, this a sub n minus 1, just means the previous term. So to find a term, take the 1 before it, in this case the 7, and you add 1 to it. Alright, so if we're adding 1 every time, so the next term then is going to be the one before, the 8 plus 1, so 9. The fourth term is going to be the one before, the 9 plus 1, so 10. And so on. You don't need to put in the blanks. I just think it's sometimes nice to know kind of what you're aiming for. So the last one here then, well, first term is 8. Make sure you just copy down that first number. To get a number, you take the one before, you subtract 3. So 8, take off 3 is 5, take off 3 is 2, take off 3 is negative 1. I'm not going to pull out the graphing calculator program again, but if you wanted to get these quicker, if you remember the shortcut from chapter 1, you can do 8 enter. That kind of sets up your first thing. And you should be able to just type in minus 3. And the answer thing will show up on your screen, ANS. If you don't trust it, or your calculator is possessed by the devil or something like that, you could do second and then your negative key to automatically put the answer in there, and then minus 3. But anyways, 8 enter, minus 3, and now every time you press enter, it'll give you the next number. So minus 3, press enter once, it gives you the 5. You hit enter again, gives you the 2. You hit enter again, it gives you the -1. So that's the way you can quickly get them with your calculator if the numbers are more brutal. For graphing these things, when we look at a arithmetic sequence, it's going to be linear because your change, really that d value we've been looking at, is just the slope. So if you were to graph these, you're going to have, like this is, we'll maybe say the x value is the term number. So this here would be the first term if I start at 0 at least, then second term, third term, fourth term, fifth term, sixth term, and so on. And then maybe let's jump back to that last one. So 8 was my first term, and I went down from there. I'm going to be off the screen if I go with that, but we'll stick with it. So I'm going to put in the 8. If we put 0 down there, 4 would be right in the middle, and I'd have my 1, 2, 3, and 5, 6, 7 up to the 8. So now the point I'm really trying to make with this graphing them is a lot of times people want to say it's right there, and that's wrong. That would be the 0th term if you were to put that there. So instead of that, if the first term is 8, you'll notice that the 8 isn't the y-intercept, it's the y value in x is 1. And now I believe we went down by 3's. Yep. So then my second term is going to be 5. My third term is going to be 2. And my points seem kind of off. We'll maybe throw this in, that's bad form, but the point I'm trying to make is we should have points, so it's a discrete graph, and they're in a straight line. That's all we have on recursive formulas.